The Sun, our nearest star, is a celestial marvel. It is a massive ball of burning gases, primarily hydrogen and helium, undergoing nuclear fusion at its core. This process releases an immense amount of energy which radiates outward and reaches us as sunlight. It bathes our planet in light and warmth, making life possible on Earth. Without the Sun, our world would be a frozen, lifeless rock drifting through space. But the Sun holds many secrets, hidden beneath its blazing surface. These secrets include phenomena like solar flares and sunspots, which are manifestations of the Sun's magnetic activity. One such secret is the corona, the outermost layer of the Sun's atmosphere. The corona is usually hidden by the bright light of the Sun's surface, but it becomes visible during a total solar eclipse. The corona is a region of ethereal beauty, a shimmering halo that extends millions of kilometers into space. It is composed of highly ionized gases and is much hotter than the Sun's surface, reaching temperatures of up to several million degrees Celsius. The corona is not just a beautiful spectacle, it plays a crucial role in the dynamics of the Sun and the solar system. The corona's high temperatures and complex magnetic fields influence solar wind and space weather. It is a dynamic and complex region shaped by powerful forces within the Sun. These forces create phenomena such as plasma loops and solar flares, which can have significant effects on space weather and even on Earth's technological systems. By studying the corona, scientists can gain valuable insights into the inner workings of our star and its impact on the solar system. Observations and data collected from solar observatories help researchers understand the Sun's behavior and predict solar storms. The corona holds clues to the Sun's magnetic field, its explosive eruptions, and the constant stream of particles it releases into space. These particles, known as the solar wind, travel through the solar system and can interact with planetary atmospheres, including Earth's, creating phenomena such as the auroras. The solar corona is a sight of breathtaking beauty, but it is usually hidden from our view. The intense light emitted by the Sun's surface, the photosphere, overwhelms the faint glow of the corona. Imagine trying to spot a firefly against the backdrop of a spotlight. The firefly's light would be completely lost. That's why we can only see the corona during a special event, a total solar eclipse. When the moon passes directly between the Sun and Earth, it blocks the Sun's blinding light. For a few precious minutes, the corona is revealed in all its glory, a pearly white halo encircling the darkened Sun. Total solar eclipses are not just celestial spectacles, they are invaluable opportunities for scientists to study the corona. With the Sun's bright light temporarily obscured, telescopes and instruments can be trained on the corona, capturing detailed images and gathering valuable data. Early astronomers, armed with nothing but their curiosity and simple instruments, made groundbreaking discoveries during solar eclipses. They observed the corona's intricate structure, its streamers and loops, hinting at the powerful forces at play within the Sun's atmosphere. These early observations laid the foundation for our modern understanding of the corona and its significance. One of the most perplexing aspects of the corona is its extraordinary temperature. The corona, the outermost layer of the Sun's atmosphere, is a region of intense interest and mystery for solar scientists. Despite being further from the Sun's core, it exhibits temperatures that are vastly higher than those found on the surface. The Sun's surface, the photosphere, has a temperature of around 5,500 degrees Celsius, or 9,932 degrees Fahrenheit. This layer is where most of the Sun's visible light is emitted, and it is relatively cool compared to the corona. This is already incredibly hot, but the corona, located millions of kilometers away from the Sun's core, can reach temperatures of several million degrees Celsius. This stark contrast in temperature between the photosphere and the corona is one of the great unsolved mysteries in solar physics. This dramatic increase in temperature, defying common sense, has puzzled scientists for decades. Researchers have proposed various theories to explain this phenomenon, but none have been definitively proven. The quest to understand the heating mechanism of the corona continues to drive solar research. It's like a campfire where the air gets hotter the farther you move away from the flames. This analogy helps illustrate the counterintuitive nature of the corona's temperature profile. This unexpected temperature profile suggests that the corona is heated by a mechanism different from the simple transfer of heat from the Sun's core. Scientists believe that magnetic waves, known as Alfvén waves, and magnetic reconnection events could be responsible for this extreme heating. These processes involve the complex interplay of magnetic fields and plasma, leading to the release of vast amounts of energy in the corona. Observations of solar flares and coronal mass ejections provide further evidence of the dynamic and energetic nature of the corona. These events release enormous amounts of energy and can have significant impacts on space weather, affecting satellites and communication systems on Earth. Advanced telescopes and space missions such as the Parker Solar Probe and the Solar and Heliospheric Observatory, SOHO, are helping scientists gather more data and gain a deeper understanding of the corona's heating mechanisms. As technology advances, we move closer to unraveling the mysteries of the sun's outer atmosphere. Section 5. A gaseous ballet. The solar corona is not a static halo, it's a dynamic and ever-changing region. It is composed of extremely hot ionized gas called plasma. This plasma is constantly moving, shaped by the sun's powerful magnetic field. The corona's dance is a complex ballet of swirling gases, erupting prominences and shimmering loops, all orchestrated by the invisible hand of magnetism. Scientists study these movements to understand the dynamics of the sun's magnetic field. The corona acts like a giant X-ray machine, revealing the intricate patterns and changes in the sun's magnetic field lines. Section 6. Solar wind, a breath from the sun. The corona is also the source of the solar wind, a constant stream of charged particles that flows outward from the sun in all directions. These particles, primarily electrons and protons, are ejected at speeds ranging from 250 to 750 kilometers per second. The solar wind is a key component of space weather, influencing the environment of the entire solar system. This solar wind carries with it the sun's magnetic field, influencing the entire solar system. As these charged particles travel through space, they interact with planetary magnetospheres and atmospheres, creating a complex and dynamic space environment. The solar wind's interaction with Earth's magnetosphere, for example, can lead to geomagnetic storms that affect our planet in various ways. The solar wind is not a gentle breeze, it's a powerful force that can disrupt satellites, cause auroras on Earth, and even pose a threat to astronauts in space. When the solar wind's charged particles collide with Earth's magnetic field, they can create stunning displays of light known as auroras, or the northern and southern lights. These natural light shows are a visible reminder of the sun's influence on our planet. The solar wind can also strip away the atmospheres of planets, particularly those without strong magnetic fields. For instance, Mars, which has a weak magnetic field, has lost much of its atmosphere over billions of years due to the relentless bombardment of solar wind particles. This process has significant implications for the habitability of planets and the search for life beyond Earth. By studying the corona, scientists can track the origins of the solar wind and predict its behavior. Advanced instruments on spacecraft like the Parker Solar Probe and the Solar and Heliospheric Observatory, SOHO, allow researchers to observe the sun's outer atmosphere and gather data on the solar wind's properties. This research is crucial for understanding how the solar wind evolves and impacts the solar system. Understanding the solar wind is crucial for protecting our technology in space and comprehending the dynamics of the solar system. Satellites, space stations, and other spacecraft must be designed to withstand the harsh conditions created by the solar wind. Additionally, by studying the solar wind, scientists can gain insights into the fundamental processes that govern our star and its interactions with the planets, ultimately helping us to better understand our place in the universe. Section 7. The corona's magnetic dance. The sun's magnetic field is at the heart of the corona's dynamic behavior. The corona's loops and streamers trace out the paths of the sun's magnetic field lines. These field lines are constantly shifting and reorganizing, leading to dramatic changes in the corona's appearance and behavior. Sometimes the magnetic field lines become so twisted and stressed that they snap and reconnect, releasing vast amounts of energy in the process. This magnetic reconnection is responsible for some of the most explosive events on the sun, such as solar flares and coronal mass ejections. Section 8. Earth's aurora, a celestial light show. The solar wind, originating from the corona, travels through space and interacts with Earth's magnetic field. This interaction creates a dazzling display of light in the polar regions known as the aurora borealis or northern lights, and aurora australis or southern lights. The auroras are a beautiful reminder of the sun's powerful influence on our planet. These celestial light shows are not just beautiful, they provide valuable information about the interaction between the solar wind and Earth's magnetic field. By studying auroras, scientists can learn more about the sun's activity and its potential impact on our planet. Section 9. Unlocking the Sun's Secrets. The solar corona, once a mysterious halo visible only during eclipses, is now a subject of intense scientific study. Space telescopes and advanced instruments allow us to observe the corona in detail, unraveling its secrets and revealing the complex workings of our nearest star. Each new discovery about the corona brings us closer to understanding the sun's profound influence on our planet and the solar system. By studying the sun's corona, we gain a deeper appreciation for the intricate workings of the universe and our place within it.